In this video, we'll learn about sorted linked list. Some applications require data to be stored in sorted order. If we have our data in linked list, we can maintain the list in sorted order by inserting nodes at proper place in the list. Now let's see how we can create a sorted linked list. Initially the list is empty. We have to insert new node with value 20. It will be inserted as the first node. Now we have to insert 10. 10 is less than 20, so it should be inserted before 20. So it is inserted in the beginning of the list. Now we have to insert 30. It is more than 20, so it will be inserted at the end. Now we have to insert 15. It will be inserted between these two nodes. Now we have to insert 35. It will be inserted at the end. 5 will be inserted in the beginning of the list. So we can see that if the new element to be inserted is less than the element in the first node, it is inserted in the beginning of the list. And if the new element to be inserted is greater than the element in the last node, it is inserted at the end of the list. Otherwise, it is inserted somewhere in between the list. Now we have taken a single linked list. So we already know how to insert a new element in the beginning, at the end, or in between the list. Now searching in a sorted linked list takes less time because we can stop as soon as we get an element that is greater than the element to be searched. For example, in this list, if we have to search element 12, then we start at this node, we go to this node, and when we reach this node, we can say that 12 is not present in the list. Now let's see the program for sorted linked list. In this program, we are maintaining a single linked list in sorted order. We have only one function for inserting a new node in the list. We don't need separate functions like insert in beginning or insert at end because they'll disturb the sorted order of the list. Inside this function only, the position of the new node will be decided depending on its info value. Now let's see this insert in order function. Here we are allocating a new node. Now if the list is empty or the new element to be inserted is less than start info, then we have to insert in the beginning of the list. And here we are inserting in the beginning of the list. We are updating the value of start. Otherwise, we find a pointer to the node after which the new node has to be inserted. So in this loop, we are finding that pointer, and after that we are inserting that new node. We have already seen in linked list how these two statements insert a new node in between the list or at the end of the list. Now this loop will terminate when either this condition becomes false or this condition becomes false. Now this condition will be false when p link becomes null, that is p points to last node, and in that case new node is inserted after the last node. This condition will become false when p link info is greater than data. In that case, p points to predecessor of node that has info value greater than data. So in this case, new node has to be inserted after node pointed by p. Now let's see this search function. Now here, if the list is empty, we'll just return. Now the search terminates in three cases. One, when the search is successful and the element is found. Second, when we reach a node whose info value is greater than the element to be searched. And third, when we reach the end of the list and p becomes null. So after this loop terminates, if p is null or p info is not equal to x, then the element is not found in the list. Otherwise, it is found in the list. Now let's run this program. So we can see that the list is maintained in sorted order.